Right now, further from home than anything humanity has ever built, a spacecraft is whispering. The signal is impossibly faint. By the time it reaches Earth, it carries a tiny fraction of a billionth of a watt. It crosses roughly 16 billion miles of empty space, and it takes almost a full day to arrive. And every time it lands, it tells us the same quiet thing. I'm still here. This is Voyager. 2 probes, launched before most of us were born, still running on a slow fading pulse of nuclear heat. And after nearly half a century, we're now watching the beginning of the end, turning it off, one instrument at a time, to keep it alive. The Voyagers left in the summer of 1977. Voyager 2 first, on the 20th of August, then Voyager 1 2 weeks later on a faster path that would overtake it. They were built for a rare alignment of the outer planets, a layout that only comes around roughly once every 176 years. Voyager 1 swept past Jupiter and Saturn. Voyager 2 went further, Jupiter, Saturn, Uranus, and Neptune, and remains, to this day, the only spacecraft that has ever visited the 2 ice giants. Then they just kept going. In 2012, Voyager 1 crossed the heliopause, the boundary where the sun's wind finally gives way to the wider galaxy, and became the first human object in interstellar space. Voyager 2 followed in 2018. Today, Voyager 1 sits well over 160 times farther from the Sun than Earth is, and this November, it becomes the first human-made object ever to sit a full light day from Earth. 16 billion miles is a number so large it stops meaning anything. Here's a truer way to hold it. In 49 years, Voyager has covered about 3/1000ths of a light year. Phoenix A, one of the largest black holes we've ever found, sits nearly 6 billion light-years away. So it's not that Voyager has gone far, it's that, measured against the universe, it has barely moved at all. A human lifetime of travel, and we're still just outside our own front door. A command sent from a control room in California takes around 23 hours to reach it, and another 23 to hear back. Ask it a question, and you wait almost 2 days for the answer. To understand why the recent news matters, you have to understand what these machines actually are. The Voyagers don't run on sunlight. Out here, the sun is just another bright star. They run on heat, the steady decay of plutonium, converted into a trickle of electricity. But that trickle fades a little every year, losing roughly 4 watts of power annually, and it never comes back. Their computers hold less memory than a single modern photo. Their instruments were designed for a 4-year tour of the planets, not a 50-year voyage into the dark. And the engineers who first built them have, for the most part, retired or passed on. So keeping Voyager alive today means reading half-century-old manuals and coaxing hardware that no living person has ever physically touched, which is exactly what makes the last 2 years so remarkable. In late 2023, Voyager 1 started speaking in nonsense. The spacecraft was still there, still transmitting. But the data coming back was an unreadable, repeating pattern. No science, no readings, just noise. The team traced it to a single failed chip in one of Voyager's onboard systems. A sliver of memory holding part of the software that packages the data for the trip home. Around 3% of that memory had gone bad, and there was no way to replace it. So the engineers did something audacious. They rewrote the affected code and carefully tucked the pieces into other, still working corners of that ancient memory, one fragment at a time. Remember the delay. Every command takes the better part of a day to arrive and another day to confirm. A single test could mean waiting nearly 2 days just to see if you'd made things better or worse. In the spring of 2024, the first clean signal came back. By that summer, all 4 of Voyager 1's operating science instruments were returning usable data again. They had, in effect, performed surgery on a patient 16 billion miles away, and it worked. Then, in 2025, came an even stranger rescue. To stay in contact, Voyager has to keep its antenna pointed back toward a faint blue dot it can no longer see. That job falls to small thrusters, and over the decades, the ones it had been relying on were slowly clogging with residue. There was a primary set of roll thrusters, but those had been considered out of action since 2004, after 2 small internal heaters failed. For 21 years, they were treated as dead. The team decided to try switching them back on, a real gamble on hardware that had been cold for 2 decades, and there was a deadline. The single giant dish powerful enough to send commands to Voyager, a 70-meter antenna in Canberra, Australia, was going offline for a long stretch of upgrades. If the fix wasn't done before that window closed, there might be no second chance. They sent the commands. They waited out the long delay, and the thrusters, silent since 2004, fired. But every rescue runs into the same wall: power. That 4 watts a year decline is relentless, and the only way to stretch the mission is to start switching things off. So that's what's happening now, deliberately, one piece at a time. In 2024, they powered down Voyager 2's plasma science instrument, the sensor that once measured the sun's wind, now silent beyond the heliopause. Then, in February of 2025, Voyager 1's cosmic ray subsystem went dark. It was still working. They shut it off anyway. And on the 17th of April, 2026, the latest one fell quiet. Voyager 1's low-energy charged particle instrument, a detector that had been listening to the space between the stars since the 1970s, switched off on purpose to save the power its probe needs just to stay warm enough to keep talking. 2 instruments now remain, one that listens to plasma waves and one that measures magnetic fields. It's a strange kind of triage. Each instrument switched off is a sense the spacecraft will never use again, but it may buy enough power to keep at least one instrument reporting into the 2030s. After that, the science ends. Then, eventually, even the carrier signal, that faint "I'm still here," will fall silent. Not because anything breaks, but simply because the heat finally runs out. And when that day comes, the Voyagers won't stop. They'll just keep drifting, silent and effectively forever. Which is why, back in 1977, someone had a thought. If these things are going to outlive us, they should carry something. So each probe carries a golden record, a gold-plated disc holding the sounds and images of a single world. Greetings in dozens of languages, a baby's cry, rain, a heartbeat, music from Bach to Chuck Berry, and a map etched into the cover, the position of our sun, drawn against a handful of pulsars so that anyone, anywhere might one day trace the path back. The record is built to last on the order of 1 billion years. The odds of anyone ever finding it are almost unimaginably small. But that was never really the point. The point was that a young species, barely out of its own cradle, chose to introduce itself to the dark and to say, "We were here." In about 40,000 years, Voyager 1 will drift close to a quiet star in the constellation Camelopardalis. Voyager 2 will glide past its own distant neighbor. They won't be visiting. They'll just be passing, the way they've passed everything else. By then, whoever built them will be long gone, or long changed. But the machines will still be out there, still holding their golden records, still carrying the map back to a small blue world. For now, though, they're not gone. For now, if you point the right antenna at the right patch of sky and you wait out that long, patient delay, it answers. Still running, still falling outward, still, after almost 50 years, whispering the same 3 words across the void. I'm still here. So it's not that Voyager is an old machine finally breaking down. It's that we built something that refused to die. And now, its quiet shutdown is the most human thing about it. We're rationing its last breaths, instrument by instrument, so it can whisper one more time from beyond the edge of the solar system. Voyager didn't fail. It's finishing its mission the only way a legend can, slowly and still talking. Follow for more mind-blowing space facts.